All right, today we're looking at 8.7, factoring special products. A special product, one of the special products we're going to look at today is something called the difference of two squares. And the difference of two squares generally means when we factor it out, we're going to have the same quantity with different signs in each of them. And you'll see what I mean when we get to the end of this example. So for the first example, we've got 25x squared minus 4. In order to factor this like a normal trinomial, we need to turn this into a trinomial. Well, right now we have ax squared plus c, or minus c in this case, and we're missing the bx term in the middle. In order to be able to factor this using slide, divide, bottoms up factoring, we need to add in the middle term. So we'll put a 0x in the middle. So we've got 25x squared plus 0x minus 4. Now we're going to use slide, divide factoring. We multiply 25 and negative 4, and we get negative 100. So we've got x squared plus 0x minus 100. A hint when doing a special product problem, you're looking for two factors that multiply together to give you a number, in this case negative 100, but add up to be 0. When you're doing that, a nice shortcut to use would be to think of taking the square root of your last term, because whatever number you have to have is going to be its opposite. So in this case, the square root of 100 is 10. The only number that adds to 10 to make 0 is negative 10. And so our factors become 10 and negative 10. So we get x minus 10 and x plus 10, and then we divide by our leading coefficient of 25. In this case, 25 doesn't go evenly into 10, so we reduce both fractions. We get x minus 2/5 and x plus 2/5. So for the bottoms up portion, we have to move the denominator over, and our final answer in factored form is 5x minus 2 times 5x plus 2. All right, so let's try a few more examples. This time we've got x squared minus 4. And in order to be able to solve this or factor this, we need to add in our middle term. Well, our middle term, we're just going to use 0x. So we've got x squared plus 0x minus 4. This doesn't have a leading coefficient, so this is just going to be factored using the easy method. So we're looking for the factors of negative 4 that add up to be 0. Well, I know right off the bat that this is negative 2 and positive 2. So I take my two factors, negative 2, positive 2, and I create my two binomials. So x minus 2 and x plus 2. And this is my factored form. Let's try one more difficult. So we've got 4x squared minus 25, and we're trying to factor this into two binomials. So we're going to add in that middle term. So we've got 4x squared plus 0x minus 25. Well, we have a coefficient out in front, so we're going to use slide, divide factoring. So we're going to take our leading coefficient of 4, slide it back. We've got x squared plus 0x minus 100. We're looking for the factors of 100 that add up to be 0. Well, I know from previous examples that this is negative 10 and 10. So I create the factored form of x minus 10 times x plus 10. But now I need to divide by the leading coefficient, which was 4. So I divide both of these by 4. In both cases, 4 does not go in evenly to the number or the factor, so we have to reduce the fraction. So we get x minus 5 over 2. And then we've got x plus 5 over 2. In both cases, we need to move the denominator out in front, or in this case, the bottoms up portion. And so we get 2x minus 5 times 2x plus 5. Let's look at a few more. All right, this time we have 9x squared minus 121. All right, so we're going to add in the middle term. So we've got 9x squared plus 0x minus 121. All right, so we'll use slide divide. So we'll take the 9 and we'll slide it back. X squared plus 0x minus 1,089. We need to find the factors of a negative 1,089 that add up to be 0. I mentioned earlier that an easy way to find these factors in the special products is to kind of just square root the last term and see what the square root of 1089 would be. Well, the square root of 1089 is 33. So a positive and a negative 33 are what we want to use. So we've got x minus 33 and x plus 33. The next step is to try to divide by our leading coefficient, which in this case is 9. In both cases, it does not go evenly into the factor, so we have to simplify the fraction. So I've got x minus 11 over 3, and then x plus 11 over 3. The last part of this is to bring the denominator out in front, and so our factored form becomes 3x minus 11 and 3x plus 11. And that is our factored form. Let's look at example 4. We've got 25x squared minus 49. We're going to add in the middle term, so 5x squared, 25x squared plus 0x minus 49. Then we're going to slide divide, so we're going to move the 25 over. We slide it over, 25 times negative 49 is negative 1,225. So we've got x squared plus 0x minus 1,225. So we need to figure out the factors of negative 1,225 that add up to be 0. In this case, we get 35. So we've got x plus 35 and x minus 35. Now we want to divide by the leading coefficient here, which would have been 25. And because 25 doesn't go evenly into 35, we simplify both fractions. So we've got x plus 7 over 5. And here we've got x minus 7 over 5. In both cases, we need to bring the denominator back out front. And then our factored form becomes 5x plus 7 and 5x minus 7. All right, we have one more. Our last problem is 9x squared minus 25. Once again, we want to go ahead and fill in the middle term as a 0. So 9x squared plus 0x minus 25. We'll use slide divide, so we take the 9 and we slide it back. So x squared plus 0x minus 225. We want the factors of 225 or negative 225 that add up to be 0. In this case, it's going to be a positive and negative 15. So we've got x plus 15 and x minus 15. We now need to divide by the leading coefficient, which in this case was 9. And in this case, it doesn't go evenly into either one. It seems to be a common theme in this problem set. And so we're going to simplify both fractions. So we're going to get x plus 5 over 3. And then x minus 5 over 3. And then we bring the denominator out in front, and our final factored form becomes 3x plus 5 and 3x minus 5. So anytime you're asked to factor a special product where you only have two terms, but you have what essentially boil down to be perfect squares, like 9x squared minus 25, in order to factor them using slide divide, you can go ahead and add in your middle term as a 0x. The 0x doesn't change any of the values. It's just a placeholder to help you see how the factoring takes place.